So our second lesson of today is a shorter lesson, a very much shorter lesson, and it's about salts. So in grade 9 or 10, I think it's grade 10, you learn about acid-base neutralization. And they tell you that acid plus base is equal to water plus salt. And they say water is neutral and salt is also neutral. And that's a very gross oversimplification. Okay, this only works if the acid that we mix and the base that we mix are strong acids and strong bases. And you add the same amount, right? So if we add a strong base to a strong acid, we get a neutral solution, right? So they kind of oversimplified and misled you because we didn't talk about strong acids and weak acids and strong bases and weak bases in grade 10, but probably all of the acids and bases that you might have used in a laboratory were the strong type. Okay, so when we have this, the cations were associated, the cations. So, okay, so when we have a salt, right, for example, NaCl, right, the first part is called the cation. And the second part is called the anion. Okay, because when NaCl is dissolved into water, okay, it will break up into a positive ion, that's the metal part, and a negative ion, right? Cation, anion. Okay, so a cation is a positive ion, and then an anion is a negative ion, and a salt is just an ionic compound, right? When we talk about salts, we're talking about ionic compounds, okay? And ionic compounds, you remember, have one part that's a metal and one part that is either a nonmetal or a polyatomic ion, okay? So it's always written in the same format, and the thing that becomes a positive ion is always first, and the thing that becomes the negative ion is always second. Okay, so when we're talking about cations, we're always looking at the first thing in the ionic compound. Okay, and the first thing in the ionic compound is the metal or the first part of the base. So what were our strong bases? Okay, our strong bases had so strong cations are group 1 elements, and magnesium and calcium, right? So we had our strong bases that were MgOH, CaOH2, KOH, LiOH, and AOH, right? So if we go back to the list, let's go back to the list of the strong acids and strong bases. Way back. I hope this doesn't make anybody carsick when we go all the way back to the strong acids and bases. Way back here, okay? Remember that a quick way to remember whether a base is strong is it starts with These three are group 1 elements: lithium, sodium, potassium, and magnesium and calcium are in group 2. But it's only magnesium and calcium for group 2 that make strong bases, really. Okay, so the metals are group 1 and group 2 metals. Okay, so you can see that in all of our neutral salts, okay, in all of our neutral salts, the metal component or the cation, the beginning, are all group 1 and 2 elements. Okay, the anions are from strong acid. So strong anions are group 17 elements, and SO4 and NO3 and what am I missing? ClO3. Okay, so right, you can see our anions, they come from strong acids. So the ending of strong acids are our group 17 elements or halogens. So we have chlorine, bromine, or iodine. Okay, and we have SO4 from H2SO4, and we have NO3 from HNO3, and we have ClO3 from HClO3, right? So you go back to the list of your strong acids, and it's really important to either have that list available to you, like it's something that you might want to put on your study sheet, or you have to memorize it. There's not that many on the list. When I was in chemistry in high school, I memorized them. And then, immediately forgot them after the exam. And then I got to university and they came up again. So then I just decided to memorize them for good. Okay. So you can see that when I have, for example, NaOH, right? My base is NaOH and my acid is HCl. NaOH is on the strong bases list. HCl is on the strong acids list. So what happens? Okay, we get NaCl. Okay, the NaOH contributes the Na plus, the cation, and the Cl minus is the anion in HCl. So it says that Na plus is the very weak conjugate of a strong base, right? NaOH is a strong base, okay? And that means that when it dissociates, Na plus becomes a very weak acid, okay? So a very strong base, when it dissociates, turns into a very weak acid. A very strong acid, when it dissociates, turns into a very weak base. Okay, so that is why a strong acid plus a strong base will make a neutral salt. Okay, the next situation that you can come across is if you have a cation from a weak base. So the cation is now from a weak base. Let's make weak bases blue. Okay, so if something is weak, I'll highlight it blue. Okay, and the anion is from a strong acid. Okay, that means overall, right, your base is weak, your acid is strong, you are going to get an acid. Kind of makes sense, right? If you don't think about it too hard, it makes sense. Okay, so the acid part that contributes to our salt is strong. The base part that contributes to our salt is weak, so of course it's going to be acidic. So here you can see that the ending of my salt is from the anions of the strong acid anions. Let me just, There we go. Okay. Right. So the Cl and the NO3, the Cl is from the group 17, and the NO3 is from NO3, right? They're all in that strong anions list here. Okay. So the endings are all from the strong list, but the beginnings, right? The beginnings that we have here, okay, they're not from our strong base list. They're not group 1 or 2 elements, right? This is ammonium, and ammonium is a polyatomic ion, right? It's not in our list of sodium, potassium, lithium, magnesium, calcium. Okay, so it says the explanation, right? NH4 is the weak conjugate acid of a weak base, and Cl is the very weak conjugate base of a strong acid. So we end up with the base part is weaker than the acid part. Okay, then we have the opposite. We have the opposite situation where the cation is from a strong base, and the anion is from a weak acid. Right? So you can see the beginnings of these salts are from the strong cations list, right? We have sodium and potassium, which are group 1 elements. Okay, so they're from the strong list, but you can see also that the anions are not from the strong acid list. The ending here, so this is acetate, right? It's not a group 17 element. It's not SO4. It's not NO3. It's not ClO3. Okay, so that's weak. Here we have NO2. Be very careful. NO2 is from a weak acid. NO3 is from a strong acid. So you just can't look and say, oh, it has nitrogen and oxygen. That's a strong acid. No, these are different. And the difference in the number of O's is the difference between a strong acid and a weak acid. So like logically, you know that if the base part is strong and the acid part is weak, that it should be basic, right? And that's because Na plus is the very weak conjugate acid of a strong base, and C2H3O2 minus is the weak conjugate base of a weak acid. So strong acid, strong base, neutral salt. Weak base, strong acid, acidic salt. Strong base, weak acid, basic salt. And then we have what happens if both of our acid and our base are weak. So what happens when we have a weak acid and a weak base? Okay, so here we have to figure out which one is stronger. Okay, and we do that by comparing the Ka value of the acid, the equilibrium constant value of the acid, with the equilibrium constant of the base, right? And remember that the higher the Ka value, the more H plus ions it gives off, and the higher the Kb value, the more OH minus ions it gives off. So if the K value is high, the higher the K value is, the stronger the acid or base it is. So if the Ka value is greater than the Kb value, that means you have a stronger acid than you do have a base, right? So if you have a stronger acid than a base, right, you're going to get an acidic salt. I think that makes perfectly logical sense. If your acid is stronger than the base, your salt is going to be acidic. Okay, if your base is stronger than the acid, right? In other words, if the Kb number is bigger than the Ka number, okay, we're going to get a basic salt. And if it's one of the rare situations where Ka equals Kb, we're going to get a neutral salt. right? So really, if you have a weak acid and a weak base, it's kind of like situations 1, 2, and 3, right? In situation 1, we knew that both were strong, so they were both equal strength. So they cancel each other out. We get a neutral solution, right? We know if the acid is stronger, we get an acidic solution. We know if the base is stronger, we get a basic solution. Okay, so the easy way to do it is to memorize the few strong acids and the few strong bases, right? So you can sort of do it in your head. But if you have two that are weak, right, you have to look up the values and compare the values. Okay, so it gives an example. Okay, it gives the example of NH4 C2H3O2. This is ammonium acetate, right? The NH4 is ammonium, the C2H3O2 is acetate. So the anion here is NH4, and the cation here is acetate. Okay, so we can look up the Ka for NH4 plus. So actually, let's back up a second. So NH4 plus is the part that came from the base, right? But the NH4 part is the weak conjugate acid of the base. So for the cation, you have to look up Ka, right? And that's a little bit counterintuitive because we know the cation came from the base, right? But when it becomes part of the salt, right, it is the conjugate acid. Okay. When the base broke up, right? So here you can see NH4 is the conjugate acid of NH3. Right? NH3 is a base. Okay. NH4 is its weak acid conjugate. Okay. So the NH4 came from NH3, but it's the conjugate acid of NH3. C2H3O2, right, came from acetic acid, but it's the conjugate base. So the anion part of the salt is the conjugate. We have to find Kb for because it's the conjugate base. Right? So it says in this case, okay, the Ka for NH4 is 5.8 times 10 to the negative 10. And the Kb for C2H3O2 is 5.6 times 10 to the negative 10. Right? So this is the Ka. The Ka is a bigger number than the Kb. When you're comparing numbers that are in scientific notation, okay, this is how you do it. Okay, so the first, you're going to look at the exponent, right? So the more positive, or I should say, the less negative, the higher the number is. Okay, for example, okay, I have to write this example because it involves exponents. Okay. Oops. So for example, 10 to the negative 4 is bigger then 10 to the negative 5. Okay, but if the exponents are the same, you need to compare the decimal number. Right? So the decimal number is the real name for the decimal number is the coefficient, right? We call 5.8 and 5.6 coefficients. Okay, so because they're both 10 to the negative 10, okay, the exponents can tell us which one is bigger. So we just choose the one with the bigger decimal number. Okay. And then we have some other situations here. So it says cations are small, highly charged metal cations, and anions are associated with strong acids. So again, we have, this is the same thing, right? Aluminum and copper are the part that should have come from the base. They're not on our strong list. Okay, the anion, the part that came from the acid, comes from a strong acid, right? So it makes sense that this case is acidic. I'm not even sure why it's there, except for aluminum hydroxide is not quite a base. If we have a metal oxide, they're always basic. If we have a non-metal oxide, they're always acidic. So if you have in a compound a metal and oxygen in an ionic compound, that's going to be basic when you dissolve it in water. And if you have a non-metal oxide like SO2, that's going to be acidic when you dissolve it in water. And that's because when you mix copper oxide with water, you get OH minus. And when you mix a non-metal oxide with water, you get an acid. Okay, so that's how we tell whether salts are acidic, basic, or neutral. And then you have some homework problems where you have to identify salts as acidic, neutral, or basic. And I'm going to go through them maybe now real fast so I don't have to come up with the homework answers. Okay, so we have here KCl. Okay, so let's look at the cation. The cation K plus comes from KOH, which is strong. And the Cl comes from HCl, which is a strong acid. So strong acid plus strong base makes a neutral salt. In our second problem, right, our K, it's the same letter. It came from KOH, which is on our strong bases list. Then we have CO3, which comes from H2CO3. And that is a weak acid. It's not on our strong acids list. So this is going to be basic. Right? Strong base, weak acid, going to be basic. NH4NO3. So the NH4 is a tricky one. It came from NH3, which is a weak base. Right? You don't necessarily have to know where it came from, but you should know that it's not on our strong cations list, okay? And NO3 came from HNO3, and that's on our strong acids list. So overall, this is going to be acidic. NAF, Na came from NaOH, which is strong. F came from HF. And again, remember, HF is the exception of the group 17 elements. So normally group 17 elements make strong acids, but hydrogen fluoride or hydrofluoric acid is the exception. It's weak. So this is going to be basic. Na2SO3. So Na came from NaOH, which is strong. And SO3 came from H2SO3, which is not the same as H2SO4. Okay, H2SO4 is a strong acid, but H2SO3 is a weak acid. So this is going to be basic. NH4Cl, NH4 came from ammonia, NH3, which we know is weak. Cl came from HCl, which is strong, right? Because Cl is our group 17 elements. So this is going to make an acidic salt. AlCl3. So this is one of our situations where, I mean, it's fine to write it like this. Al came from, if it had a hydroxide, it would be Al, and if you do the crossover rule, AlOH3, it's not on our strong bases list, it's weak, right? And Cl comes from HCl, so it's strong. So this is going to be acidic. N2O, this is a non-metal oxide, right? So whenever the anion is oxygen, you have to look at if the cation is either a metal or a non-metal. In this case, it's a non-metal. So non-metal oxides make acids. So this solution would be acidic. NaClO4. Okay, so the Na came from NaOH, which is strong. The ClO4, that's not the same as ClO3. It came from HClO4, that's perchloric acid, which is weak. So this is basic. NH4Cl, I think you can start to get the idea, right? NH4Cl, that's going to be acidic. The next one is going to be basic. And the last one is a metal oxide. So it'll be basic. Okay, and then it says find the pH of the following solutions. Did I give you an example? I did not give you an example. Okay. We'll do should we do one of these? Nah, I'm gonna let you off easy. Okay. I won't have you come up with the pH of salts. Maybe a little bit later, if I have some time, I can show you how to come up with the pH of salt solutions, but I would say it's not something that you need to know for your test and not something that you need to know for your exam. So more likely, I'm just going to give you a salt and ask you if it's basic, acidic, or neutral. So this is the really important part of this lesson. Okay, the other stuff it's a little bit on the advanced side for you. But again, I might do a practice problem later that gives you the format for finding the pH of these out. All right. So that's the end of the lesson. Tomorrow we are going to have our last lessons in equilibrium. We're going to talk about titrations of strong and weak acids. I think we're going to do a titration lab, an online lab, where you get to understand this better, and then test time, right? We'll have a small quiz on all of the equilibrium units. So that's it. Make sure that you're taking a look into the Le Chatelier quiz that I posted yesterday. Make sure that gets done. Make sure also the equilibrium and concentration lab that I gave you earlier in the unit gets done as well. But that's what you should be working on. And of course, it is now the 14th, and our final exam is on the 26th, right? So we're starting, it's now 12 days away. So remember to start making study notes and reviewing the material. Also, no, that's it. Okay, so have a great day, and we'll see you in the next class.
Bye, ma'am.